The Fine Fuel Moisture Code, or FFMC, is a key factor in tracking the potential for fire ignitions and flammability of surface fuels. In this presentation, we'll discuss fuels that the Fine Fuel Moisture Code tracks, where the FFMC fits into the Fire Weather Index system, how the FFMC is calculated, and some of its important thresholds and interpretations. Let's consider these four representative depictions of fine fuels in the landscape of Alaska and the Lake States. The first is needle cast under pine, spruce, and fir forests. The second, in the lower left, is hardwood leaf litter from oak, maple, aspen, and birch forests. The third, in the upper right, shows deep feather moss fuel beds from Alaska. And the fourth, grassy openings, occur in disturbed areas and old burn scars found throughout the landscape. No one index can represent the change in fuel moisture among all these fuel types. However, the Fine Fuel Moisture Code provides a reasonable compromise among them. This process flowchart shows how the codes and indices of the Fire Weather Index system are related to each other and the system inputs. The FFMC uses all four of the weather elements collected at solar noon: temperature, relative humidity, wind speed, and 24-hour precipitation, using them to increment the FFMC up or down depending on the current conditions. Beginning with yesterday's FFMC value, the calculation first determines whether rainfall was significant. If so, FFMC is lowered to what is called the rain code. After that, using either the estimated rain code or yesterday's FFMC, solar noon values for temperature, relative humidity, and wind are used to determine how much the atmospheric conditions affect FFMC. The process is essentially an accounting system, with rainfall reducing the balance and warm, dry, windy conditions raising the balance, producing the current Fine Fuel Moisture Code. The FFMC is the numerical rating of moisture content of litter and other dead fine fuels. The daily FFMC is an indicator of daily fire occurrence and peak daily ignition and spread potential. The FFMC ranges between 0, which represent wet fuels that are saturated with moisture, and 101, representing no moisture at all. The scale at the top of the screen shows some common thresholds. At 80, significant fire occurrence becomes more possible. However, since it represents shaded litter fuels, cured grasses may begin to carry fire at lower levels, perhaps 70, especially with wind when the FFMC is increasing after a rain. Forest fuels support significant spread above 86. Spotting problems increase at 89, and extreme fire behavior is anticipated above 92. 96 is typically the highest value found in our climate. This diurnal plot of hourly FFMC and hourly grass fuel moisture code, or GFMC, includes the daily FFMC as well. The hourly FFMC in blue represents a 10-hour time lag for fuel moisture. It shows the diurnal day-to-night trend, with the highest values during the afternoon of dry days and a muted overnight decline. The hourly grass fuel moisture code in orange shows a more responsive trend, increasing more rapidly during the day and declining to lower levels overnight. Note the daily FFMC, shown as a black diamond with the dashed box around it representing the peak burn period. It appears to provide a good compromise value during the peak burn period, falling between the two hourly values. It is easy to spot a rain event with dramatic declines in both the blue and the orange lines. Notice how much more quickly the grass fuel moisture code responds after a rainfall. Though FFMC is not presented as a fuel moisture, it is related to them. It represents a time lag of about 10 hours for shaded forest litter fuels. In fact, the calculation of daily fine fuel moisture code requires conversion to a fuel moisture and back to the code. FFMC can be represented as a fuel moisture. The graph here is an easy tool for that conversion. If the FFMC were 90, the corresponding fuel moisture is 11%. Using the NFDRS fuel moisture stick, 10-hour fuel moistures were measured for many years at fire weather stations. Using 20 years of this data from Michigan, FFMCs were compared to fuel stick moistures where the sticks were unshaded. The orange diamonds on the graph represent this relationship. Using the earlier example, an FFMC of 90 is compared to about a 9% instead of 11% fuel moisture. This perhaps shows the effect of shading on those 10-hour fuels. This one last graph shows an entire season of daily fine fuel moistures, estimated from FFMC and from NFDRS 1-hour fuel moistures. The green line represents the daily FFMC through the fire season at the Saltjaw, Alaska RAWs from 2013. The blue line represents the older 1-hour fuel moistures from the Fosburn fuel moisture model. Most of us have used this when estimating fine fuel moisture from the Appendix B. As expected, its 1-hour time lag moistures are lower than FFMC throughout the season. The orange line shows daily 1-hour fuel moistures as it will be calculated in the new NFDRS 2016 using the Nelson fuel moisture model. Interestingly, the new 1-hour model produces fuel moisture estimates much more like the FFMC-derived fuel moistures that represent a slower time lag for shaded fuels. We've considered what FFMC represents and how it might be used to interpret the risk of ignition, fire start, and fire spread. Now the question turns to the importance of forecasting FFMC and what might mean to the decisions on fires. For most fire managers, forecasts of FFMC are available online from individual weather stations and across broad areas. But it is possible to estimate the FFMC value using weather forecasts and the lookup tables available in field guides. In summary, the Fine Fuel Moisture Code does a good job of indicating when fire occurrence becomes possible. It represents fuel moisture for a wide range of surface fuel on our landscapes. FFMC calculates fuel moisture for a 5 to 16-hour time lag that best characterizes conditions under shaded forest canopy. The daily FFMC value produced for the FWI system is a pretty good estimate for the peak burn period. Now that you've finished this presentation, consider the other fuel moisture presentations to become familiar with the FWI system. Thank you.